into 15
into
7.5. 6
minus 6 into 8. 3 into 16.
That's all, and then this plus 15 into
1. Yes. No.
the sum of all moments is equal to 0 for equilibrium, and you will get from here MA. So once you have MA, everything is solved. Do you understand or not? I come back, but your homeworks remain still there. Now I told you this is B A and it is B B. So now BA is equal to BB, you know this.
Yeah.
This is HA and M is how much? Whatever. You know this value, you know BA. Only HA is unknown, and now you can apply sigma fx, or you can apply, because there is one more here, I think it is HB. So you can take a moment here, you will get HA, because you know this moment, and once you have HA, you can apply sigma fx, you can get HB. Is there need of homework, or you can do it?
Yes.
Well, try this at your home. But this is the only trick, the moment, which I explained to you right now. Okay? First, divide into components, like this member separate, the other member separate, this member separate. Apply sigma fx, fy, sigma fx, fy, you will get the whole vertical reaction up to this point. And then consider this structure as a whole. 3 reactions here, 2 reactions here. Apply sigma m, you will get this m. This is the only thing. Well, I don't want to teach you this today, but we have done it. If you still want me to solve one example, I can do that.
Victor, we want the example with frame with no pin connected.
We already did. No,
That's how we cut it. We consider that as a joint?
You mean this?
No. The before one, but in the frame
This
condition. No, there is a joint. No, there is something, just one
X.
It's all fixed.
We did in our last class.
Yes, but
Frame.
not frame, we did just the half.
No, we did. Before that, we did some problem, something like this. If I remember,
Yes.
there was a load like this,
Yeah.
and 2 reactions, something like this, and you have one vertical load here.
Yes.
Yeah.
You.
It is fixed.
So how we cut it, Victor?
No, we did not cut.
We cut it and make the reaction.
We, for example, we just consider first this part, then we apply sigma fx fy, and then we made this joint,
Yeah.
we made an equilibrium, these forces we transfer from here to this B.
We have to, Victor. We have to separate it. Because
Yes.
it's just one shape.
So we did that.
Okay, we have moment also in this,
Here,
in the corner, up corner.
yes, we also have the moment here. I remember there was a moment. So then you transfer this moment from this joint to this joint. Just revise my previous lecture. You know, I told you, if you do not revise your previous lecture, it's gonna be very hard for you. Structural analysis is not like history or some social sciences, so that if you come back, everything will be in your mind. Until and unless you repeat or you study the previous class,
I don't understand.
now you are at the peak of shear force and bending moment diagrams for the beams and for the frames. And from here we will go to the next level. We will not go down. Okay? Do you have any other question? So this frame, there is a fix at A, but in our last class, for example, if there is a fix here, so moment M. Now you cannot solve this frame. Now this frame is known as indeterminate frame. If a frame has two fixed supports, one fixed support here, another there, it will become indeterminate. You cannot solve this frame now. Do you understand?
Yes.
Two fix, but just one fix we can solve it.
Depends.
Two fix we cannot solve.
You have to apply the equations for determinacy and indeterminacy. Okay? You have to check. Okay, what is one last thing, let me tell you, and I think today we have done with this lecture because we are left just with 30 minutes. But I really did not plan to teach you all this. But now we are left with a very limited time. The only thing which I wanted to tell you now is the method of superposition. What is that? Any one of you can explain me?
Superposition is still.
I think I already told you this before.
Yeah, to make something stable or something like that. To connect like a hinge with a roller.
What is that? If you have a beam and on this beam you have two loads. One is point load, this one, and the other one is UDL. This beam, let's suppose the okay. You wanted to solve it. How you can do that? You can divide this beam into two parts. One beam with 1 plus UDL.
Two states.
This is the marker here. Okay, and you will find reactions. So this will be equal to, this beam will be equal to the two parts. So these reaction will be the sum of
Summation of.
these two reactions, and the same way you can draw the shear force and the bending moment diagrams and you can combine them. For example, you can find two moments and the sum of two moments will be equal to the moment at this point. Okay, this method you can use this, but it's not preferable because you have to make two bending moment and two shear force diagrams.
Yes, teacher. What if the point is different?
You mean the load is here?
Yeah, like exactly.
No problem at
Bending
all.
moment.
It will be perfectly same. But for that, your material should be elastic and it should follow the Hooke's law. That is the main condition. If your material become non-linear, non-elastic, then I think you cannot use this for yes, for design or for analysis. Then you should use other method. Then if it is not cracked, if it is before crack, you can use finite element method. Or if it is cracked, and then separated, you can use applied element method, or you can use distinct element method, which is, I think, beyond your scope. That is something researchers area, or that is the researchers' boundaries, and I don't want you to bring there right now. Okay. Well, now what next? What actually I planned you to learn in this class was the same thing but with the computer. Okay. You know, for determinate, like I told you, if you have a frame, this joint is fixed joint, not pin. So, in that case, the degree of determinacy will be 0. But if you make even 2 hinges, now the degree of indeterminacy will become +1. And you cannot solve this frame by these methods. In that case, you have to use special method, that is a finite element method. Okay? Or there are some other methods for indeterminate structure. Similarly, for example, if you have a beam, let's talk about this beam. Or one roller, you have a UDL on this beam. How many reactions? 5. How to find these reactions? How? No, it's a one part. No hinge. It's one beam.
Undeterminate to the.
For example, it is W. You mean divide into this way?
No, it's not so.
No.
It's not so.
sections.
For force and the other for UD.
I did not understand.
This one.
You mean-
one reaction, but then
You can tell me. I mean, if I'll try my best to understand what you are saying.
I mean divide the UDL in the separate one and the other reaction separate one.
He means superposition.
You mean the method of superposition? But I need the reactions. How I can get the reactions? If you apply sigma Fy,
It's indeterminate to the second degree.
For reaction الوان
1, 2, 3, 4.
4 unknown, 5 unknown.
No, 4.
the next one.
Yeah, if there is no horizontal, then 4. But if there is a load like this, so it means now there are 5 unknown. How to find now? How to find?
By ratio.
Then, in this case, this structure becomes indeterminate. Similarly, if you have a frame like this, how many reactions now for the whole structure? 9.
9.
How to solve it?
9 reaction.
Yes. Have you seen a frame of a building? It is a 2D frame, 2D frame. If I make this frame in 3D, like one column is also here. So how many reactions now? 18. Only a small 2-bay. If I make it 3-bay, you understand? And you know, at each joint there are also 3 reactions. 3 forces. At each joint there are 3 forces in each joint. How to solve this structure, this frame? Have you seen a building frame? I think when you go nearby, our ultimate goal is structure, not frame. You will not design frames. Maybe sometime you do, like in steel buildings. But for the reinforced concrete building, the most of the time you have to design frames which are multi-story and which have huge area, which have so many number of bays in both directions. how to solve it, how to draw the shear force and bending moment diagram. Just think in your mind. Can you do that?
Just close the book, leave college of engineering.
No. Then we have the computer aided methods. Okay? From indeterminate structure, the stiffness method and the finite element method, they comes into action and they take responsibility for all these things. So then you make a matrix. Then it comes mathematics. I wish I can teach you the stiffness method. It's my wish, my desire. But I cannot fulfill that in this course because it is not included in this course. Okay? And for that, but I mean, if you do not learn how to solve this frame or how to find the reactions, how to find the shear force and bending moment, then I think you feel something missing in yourself as an engineer. Am I right? If you graduate and you don't know how to analyze this frame, then I think there is a big flaw, there's a big loophole in your mind, and you will always miss, and you will always say that, I mean, our college, I mean, they did not help us and we cannot learn. But what I can do, if I have to solve this frame by the same methods, then maybe I need at least 6 weeks to tell you about all these things. But because we have a huge and intensive course, so what I'm going to do, I will tell how to analyze these frames in computer, so that at least you can do something. And for your surprise, 99.9% design of such frames are carried in the computer. No one do using manual or hand calculation.
It will take forever.
So it's a kind of good news, and it should make you happy that once you learn this, it means you can use it for your real design, for your real structures. Do you understand or not?
Yeah.
So that is the first step, and we have three programs which we can use for computer aided analysis. The one is SAP, Structural Analysis Program. The other one is STAAD, STAAD. SAP, STAAD. Structural Analysis Program, Structural Analysis and Design Program. Well, it also do that. It also design. SAP also design, but that is not included in the name. Okay? So, I give you a choice. Which one do you want to learn?
Which one is more common in like field of jobs?
For concrete buildings, the first one is more common, and for the steel buildings, second one is more common.
The first one.
First one.
And second one.
Relevant to this SAP, we have, but remember, these two are two opposite directions. STAAD is totally different from SAP. If you know SAP, you cannot use STAAD. If you know STAAD, you cannot use SAP, but you need only one. For example, let me show you one of some of the drawings. I use, when I teach most of the time SAP, but when I use STAAD.
Why?
Because
Most of your work with steel design.
Because my specialty is more towards steel. Okay, like concrete design. But for example, many of my friends they seek my help in SAP, ETABS, and SAP. Okay, Alhamdulillah, I'm a good user of I will not say expert, but I'm a good user and in-hand knowledge of these programs, most of these programs. And most of the people, they seek help in this context, but if you talk about my use, I personally use STAT. For example, I recently done some project, very big project. It's a kind of petrochemical industry, petrochemical company. It's a kind of refinery, something. It's not located in Saudi Arabia, so, and that project is not in Saudi Arabia, that's somewhere else. So, but I did only in the steel. I did the modeling and everything, and I prepared the drawings, everything on STAT. But SAP is much more versatile. It's highly appreciated, acceptable, more features, more easier to use, better graphical interface, and it has connection with many other applications. Okay? So let me show you. I show you something. Safe. It is for foundations. Just hold on for some time. Problem which I just discussed some time ago. Can you start your attendance from here? Okay, now in the next class I'm going to teach you how you can solve such types of indeterminate structures using computer. I mean, yeah. Like there are some, for example, it is like 3D frames. You can see here, it is 2D frames. Like you can tell, for example, the frame which I just prepared in front of you, 2 number of stories, 2 bays, bay width is 3, and the story height you can say 4 meter. And if you click OK, you can see that 2D frame. This is the same frame, but here the sport is hinge. You can convert this sport into the fix. Yes, now it is a fixed support. Do you understand? So in our next class, I will teach you how you can analyze. Analyze means how you can draw the shear force and the bending moment diagrams of such indeterminate structures using SAP. Yes.
Does it give like a like one number, like this reaction is like, for example, 50 kilonewtons, or does it give it a range?
It gives a perfect value, like it depends upon how many types of load you are going to apply. If you apply one load, it will give you one reaction. If you apply 10 different types of load, it will give you 10 different types of reaction. For example, in the real design, we apply many types of load: dead load, live load, lateral load, lightning load, false ceiling load, earthquake load, wind load. So we get the reaction for all these loads. But what you can do for the gravity loads, you can combine the whole number of gravity loads. Dead and live you can combine, and you can get one reaction. You understand? But it can give you as many types of load as many you want. For example, if you go and see the different types of load, the load patterns, you can have like dead, super dead, live, reducible live, roof live, pattern live, notional load, quick load, wind, snow, temperature, breeze live, wave, LL structure, wind and live load together, locked in, or horizontal earth pressure. There are so many types of load which you can apply.
What is the difference between that and super dead?
Dead and super dead. Any one of you? The super dead is like Superman. No, it's not like that. Dead load, there are two types of dead load. For example, one is the itself weight of structure. The self weight of the structure, that's a dead load. And super dead load, for example, if you put tiles on this floor, if you put sand, if you put any thick layer of any material on this floor, so that becomes super dead load, which is above dead. Do you understand?
Yes.
So that we call super dead load. Okay, but there is no super light load. Okay. So we will learn. I had a plan to tell you in 2 classes about this software. I think it's enough. The rest I will refer you for my videos, which I will give you. I mean, I already have so many videos about how to analyze and design for SAP, for ETABS, for SID. So, but here I will give you just as a beginner level videos, just beginner level introduction, because let me see if I can find SAP. What I wanted to write, introduction to I think SAP, introduction to complete design software. Type my name, it should come. Yes. Okay, so this is a tutorial, and this is the second part. You can see the first part as well. And yes, I think from the it tells you each and everything. I mean, this tutorial is